Okay, good morning everyone and welcome to the third IES faculty event. Today we're going to be talking about BIM integration with the virtual environment. So thanks for coming along in the first instance. My name is Sarah Graham. I'm the IES UK sales manager. For those of you who don't know me, I do know quite a few people that are here. And today I've got with me my colleague Michelle Farrell. Michelle heads up our European division. But she's also one of our BIM experts, shall I say. So she's very kindly agreed to come along and help me out today. What we're going to do, it's a 3-hour session. Largely what we're doing today is bringing you some lessons learned and some practical advice on integrating BIM. We will focus on Revit a little bit, but a lot of the principles apply regardless of which BIM tool it is that you're using. Okay? So we're going to look at the what, the why and the how, if you like. The session breaks down, as you can see there. Okay, so I'm not here to tell you all about BIM and teach you what that actually is. What I will say is that it can mean different things to different people. I'm guessing that most people here will consider BIM to be a 3D model. Okay? But if you take the term itself, building information modelling, it doesn't necessarily have to mean a 3D model. It can be any means of modelling information with regards to a building, okay? But the key there is being able to create that information, you know, store that information and then share the information between different applications. So that's the idea really, that's where we're coming from. We are in a situation now where there is an acceleration of the uptake of BIM within the UK industry, and there are reasons for that which I won't necessarily go into today, but we find ourselves in a position now where we are starting to move from 2D to 3D, but beyond that there's a whole world of BIM to be considered, and as designers that's really for you to take on board. Okay? So the situation, as I say, that we find ourselves in now, typically we have, if we do stick to the sort of 3D representation that we're kind of familiar with, we'll have a composite model which holds a lot of the information related to that building. So that will be building elements, it could be the activities which take place within the building, all the data assigned to the elements themselves, it can be the systems, performance data related to those systems, all in a composite model. And then we have a number of purpose-built models created in different applications which interface with that composite model. Okay? So the situation, as I say, that we are in at the moment is one where we have the same data shared between different applications. And that exchange of data is called interoperability. So what BIM does, within a BIM-enabled collaborative approach to design, it's fundamentally different from a traditional design approach because the information exists in a sort of centralised location and it's available to all members of the design team, the client, the owner, the contractors can all access that information. So it means that the information is much more readily available, it's up to date and it's correct. The traditional approach then typically sees technology being used in isolation. So the architects are doing their thing with their pieces of design technology, the engineers are doing their thing with their pieces of technology, the structures, the cost consultant, all these people are doing their own things, largely in isolation. With an integrated design process, a collaborative process, what we're talking about is design technology in collaboration. Okay, so constantly being able to pull out information from that composite model, run analysis on it and feedback, that sort of thing. And what that does is facilitate, the integration itself facilitates better design because you're able to evaluate more options from the earlier stages of the process. So you have a lot more of the answers as you progress to the next stage of the design process, okay? So just looking at that in a bit more detail then, with a conventional design process, very linear, we have the architect and the client, for example, setting out the brief at the beginning, which may right at the sort of early stages of design, which may involve creation of a concept model, maybe a sort of very simple massing model which looks at the shape of the building and possibly starts to look at the layout. Somewhere further down the line, the engineers come on board and they then implement that design, if you like. They do their design on that basis. A lot of the decisions have already been made. This is all stuff that I'm sure you are familiar with, but it's kind of setting the scene for later on. If we look at the involvement then of performance analysis tools, that doesn't happen until well into the process, typically. I'm not saying that there aren't examples of companies here who are employing performance analysis earlier on in the design, and that's really what we're driving at here. That can present problems, especially if there are aspirations on the project for a particular level of performance. So if it is BREEAM excellent or you know, a certain level of EPC or something like that, the earlier on we can start to address those requirements, the better. So we see here on the right hand side, the graph indicates that most of the effort takes place around the construction documentation phase. There's not a lot of time for analysis and optioneering earlier on in the process. It basically becomes a race by the various disciplines to get to that point where they produce their information and send it out, and that's them done. I mean, you can correct me on that if you're wrong. This is our view, I guess. So, as I say, it doesn't really allow a lot of time for interdisciplinary collaboration at the earlier phases. So this is getting into the why now. I've sort of outlined what BIM is roughly. We're moving into why would we use it, what are the benefits really. So with the BIM-enabled integrated design approach, we do have more information earlier on. It is shared between the different disciplines, therefore different studies can be carried out on it. You know, the issue that design teams face at the moment is that fees are being squeezed, timescales are being squeezed, so the opportunities to do this sort of evaluation and optioneering is becoming more and more difficult. The opportunities are reducing. So I think by introducing BIM into the process, this can address those issues to a degree, because basically you're getting a 3D model fairly early in the process which you can start to do some stuff with. Can we collaborate without a model? Yes, of course we can, and we have done that and we will continue to do that. But the advantage that this BIM-enabled approach gives us is to be able to actually measure the performance, okay? So obviously engineers and architects have integrated at various points in current examples as well. But with the models in place, that gives us the ability to do a lot more earlier. Whether that evaluation is environmental performance or whether it's cost or whether it's buildability, there are a whole number of different requirements that will be set for the project that can be evaluated earlier. Okay, so we're looking at what is the best option, or what are the best options for this particular project on this particular site. And also being able to capture that information allows us to hopefully to avoid revisiting the same design decisions multiple times through the process. You know, if it's captured and it's documented as the design develops, then we don't need to come back and ask the same questions as we move into scheme design and further. So the integrated approach to design doesn't necessarily involve any different roles. I mean, you can see the typical roles down the right-hand side there. But what it does do is take established processes and integrate them into a sort of more systematic overall process. Okay? And for me, that becomes particularly relevant where we are pursuing an environmental rating system. So I'm going to use BREEAM as an example. We know what the requirements are from the start. We know what we're trying to achieve. So the sooner we can start to address those, the better. I think I said that earlier. And then we can develop a process map around that. So we know what the requirements are, what information needs to be produced to meet those requirements, who's responsible for producing that information, when does it need to be produced by. Okay, so that's really what we're talking about with an integrated design process. BIM is only a tool within that solution. It's not the be-all and end-all. And that's an important point, actually. The technology exists, the technology is there to a degree, but what has still got to change, and what is a bigger hurdle, I guess, to get over, is people's mindsets and also the processes that we currently undertake. Okay, so how do your design process, the way that you approach design, does that actually lend itself to a more BIM-enabled, integrated approach? Are you able to integrate with your other disciplines? Okay, so even where we don't have BREEAM or LEED or an actual voluntary environmental rating scheme, there are other questions that we as designers will be asking as the design progresses. And even, you know, as a fundamental requirement, carbon and energy is a key metric on projects. And the sooner you can start to get feedback on those, again, the better things will be. And what we're looking at here is really a driver for the uptake of BIM and looking at the, I suppose, the asset management as well, the whole life of the building. Okay, so we, IES, are coming at it from an energy and environmental performance perspective, but BIM opens up a whole world of possibilities. And part of the reason for the acceleration of uptake in the UK is to do with asset management. So on into the operational phase of the building, looking at maintenance and things like that. Because all that data exists in the BIM model, then you're able to maintain it. Okay, so just continuing on with the why then, why would we use this approach? The following slides just outline some of the typical studies that we can do starting at master planning. So we can start to look at current and future climate predictions. For this, you know, we can use a very, very basic 3D model, or in fact no model at all, because what this is doing is looking at the climate file for a particular location and providing advice with respect to more passive design for any building designed in that particular climate. Okay, so that's just one example of the sort of study that we would typically do at a very early stage in the project. And then that starts to feed into the design itself. Okay, concept design, we may be looking at multiple options in concept design. We'd be getting some comparative studies out of that. So, you know, does a a tall model with a fairly compact footprint building, does that perform better than a low-rise version, same gross floor area, which is more sort of dispersed in its footprint? We can start to refine things like orientation, solar shading, glazing percentage, but still at a fairly high level. So making decisions as we get feedback from the model, okay, from the analysis. Into schematic design, we might have a preferred option. We can start to look at compliance, so UK compliance with Part L, EPCs, again BREEAM, or if it was elsewhere, we could be starting to get some early feedback on LEED performance as well from the earlier stages. Again, refining the data, so integrated feedback on the glazing configuration, for example. That will give us feedback on energy, daylighting, any glare issues that we might get. We can look at all of those things within the software. And then in detailed design, really what we're talking about here is a submission quality model, okay? So what the model that we're going to be using with all of the detail refined in it, that would be then submitted as part of your BREEAM certification or producing your Bruchel document, for example. But this introduces quite an interesting point in terms of the management of the BIM model. Because going through these slides here, it would look like it's just the same model that I'm taking in and then developing that through those various stages. In reality, the workflow is more likely to be bringing a different BIM model in at different stages in the process. Okay, that's typically, so the architect will develop that and will be changing layouts and maybe changing shape and stuff like that of parts of the building, and then the engineer is bringing those new models across, if you like. With BIM, Revit in particular, it's very easy to build a lot of detail into those models early on. And that's kind of what they're aimed at. Revit is a production information tool, so you can build lots of information into it. And those of you who have tried it will know that that fully detailed bells and whistles model will take a very long time to come across to the analysis software. And in fact, once you try and run any analysis on it, it will take a very long time to do that as well. Now, there are reasons for that, which again we will cover later on in a bit more detail. But I think the key point here is, if you're going to be trying to do this, to implement this integration between the two, you need to be very careful in planning your model for export. In simple terms, what I'm saying here is keeping a stripped down version of the BIM model for export, okay? So not one with all the door handles and all the light fittings and the balustrades and every possible bit of detail in it, but something much, much simpler, okay? And this will become more apparent as we go through. So within our software then, we have a tool which will basically gets over the issue of overwriting data every time we bring a new model across, okay? It's called Model Merge, and what it will do is simply compare an existing imported model with a newly imported model, and it will flag up any changes in the floor areas, in the room volumes or the room names, and it will ask you if you want to retain the thermal data that's been assigned in the existing model to that new model. Okay, so you don't overwrite everything whenever you bring in a new Revit model. So those are the whys. I think we're moving into the how now, finally. Okay, so you will probably know, for those of you that are familiar with IES, will know that we have been working with Autodesk and Google over the past 2 to 3 years, except in the fact that SketchUp is not a BIM tool, but it's on there by way of explanation of what we've been doing. We have done work with Graphisoft as well regarding the ArchiCAD import. We can use a raw GBXML import from MicroStation or Allplan, for example. So we have the means to bring the data in from various different packages. And this gets us over one of the biggest hurdles to performing the analysis early on, and that is rebuilding the geometry. Okay, in days gone by, that is what we would have had to do. It takes another 2 weeks, or 4 weeks or whatever to do that, depending on the size of the model. So that slows down the process, and typically, historically, engineers have been reluctant to do any analysis until they have a more or less fixed design. Okay, but what we want is the analysis to be brought forward so that it's actually driving that design and optimising it as we go. So potentially this shifts the dialogue between the architects and the engineers to one where they're able to use the same tools and collaborate much more easily. We equip architects with early stage tools to be able to do their preliminary analysis for themselves. In an ideal situation, the disciplines then understand the context of what the other disciplines are able to do and what they are trying to do right from the start. And as I keep saying, better integration, better design should be the outcome. So in practical terms, how does it work? With Autodesk Revit Architecture and MEP, we have a free plugin which you download. It installs a toolbar within Revit. And from there, you can set up the model. So you can assign a location to it, you can define some constructions, building types, there's a template of information there for offices, for schools, for laboratories, etc. Once you've set up that information, you can then launch whatever level of our software you want to look at. So we've got VWare, which is a free tool. We've got toolkits, which is a sort of not free, but a fairly simplistic interface, really aimed at architects. And then we've got VE Pro, which is the fully sort of detailed, all singing, all dancing level of our software. And then progress and do whatever types of analysis you want to do with it. This gets a little bit technical. The purpose of going into explaining how GBXML works is really just so that when you are creating the Revit models, you have that in your mind about how we use GBXML to translate the geometry from Revit or ArchiCAD, for example, across to the virtual environment. There might be slightly different methodologies depending on the BIM tool that you're using, but I mean, we can offer advice on that as well. We will always support you in your efforts in trying to make this work. So the hierarchy then relates to the plugin that I've just described. We have the geographical location within GBXML, which we use, which then determines the climate file that's used for your thermal, your energy calculations, your dynamic simulation. Okay, we have building type, so we've set up a number of different templates with occupancy densities, occupancy profiles, lighting profiles, that sort of thing, for different types of building and different types of room. We have rooms themselves, which is obviously critical. For analysis, we need bound volumes, and this is going to be key. And for those of you, again, that have been looking at the integration already, you'll know that you know, there are certain rules to follow to get those rooms to come across, which you can then perform your analysis on. If the rooms don't import for whatever reason, that creates an issue, because then we've got effectively a hole or a gap in the model. Okay, so when we run analysis on that, the room adjacent to that hole sees that as it's an external, an external zone, if you like, which will then affect energy flows through that the wall that separates the two. Okay, so rooms are critical. We differentiate between rooms and shading surfaces because we want to be able to bring in elements. So it could be louvers on the exterior of your building. It could actually even be an adjacent building to the one that you're doing your analysis on. We want those to come across. They will impact the building that we're looking at because they'll overshadow it, they'll block solar gain, that sort of thing. But we don't want to include those in, for example, the carbon footprint calculation for the building that we're interested in. So we need to take account of them in such a way the software knows they're there but doesn't actually include them in the carbon energy calculation, for example. And then obviously we have surfaces, which are walls, floors, roofs and ceilings, which bound the rooms, and then we have openings finally as well. So GBXML then describes elements using a common language, shall I say that? Michelle will probably correct me on that. But that's the purpose of it. The Green Buildings XML schema was developed to enable this integration, this exchange of data from architectural or 3D modelling packages into analysis packages. It's fairly simple in its approach. It's not perfect by any means, but it's what we have. It's a kind of lowest common denominator for us to work to currently. So it's kind of phase one, I guess, for us in this respect. In being able to map the, say, Revit or whatever BIM tool it is, map that geometry to the VE, how it understands geometry, it has to use common descriptors. So an example of that would be adjacency. The virtual environment uses adjacency to decide whether surfaces are internal or external, and it applies constructions to them on that basis. So it knows that a wall is external and it will apply an external wall construction on that basis. Okay? And that's important for analysis. If you define or denote a wall as external in Revit, that wouldn't mean anything to the virtual environment. Okay, so it's actually looking at, as it explains there, adjacencies. So, you know, a ground floor slab is understood to be something that's a horizontal surface not in contact with any room below it. Quite simply. And so on. So interior walls, interior windows, skylights, that sort of thing. So that's all defined by adjacency. So rules or guidelines, all of this is taken from our guidance documentation, which is on the website. You can download it from there. You can pick up a card and email myself or Michelle and we'll send it through to you. Not a problem. So I suppose there are some golden rules. One is keep it simple. So if you follow the KISS principle, that will stand you in very good stead. If it's a centralised model, detach from central, clear out anything from the model that is not going to be relevant for analysis, purge any unused elements as well, just to reduce the file size. Use the appropriate family type for custom components, excuse me, choose the lowest level of complexity, and I think Michelle will cover that in the demo as well. So there are different levels of complexity that you can export. Use the lowest one that you think you can, you know, for the purposes, for the stage in the design process that you're at and the purpose of the analysis that you're actually going to be carrying out. That can mean the difference between 50 or 500 shading elements. So that will significantly slow down or speed up the export in the first place. And it can mean the difference between minutes and hours in running an actual simulation as well. Non-room bounding seems to be one of the key tools that we have to simplify the BIM models that we bring across. And there are a number of examples of this within the documentation. I'm only going to pick out a few today just to explain, explain the principle to you. So columns is a very good example. In the sort of top images there, I don't know if you can see with the colours, but the columns are set to be room bounding, okay? And that creates a situation in the virtual environment which it doesn't really deal with very well, where it sees a room within a room, okay? Just by setting those columns to be non-room bounding, we get quite a clean room there that we can import very easily. Same sort of idea, same rule for what we call jogs. So a wall, but part of it actually kicks into the room. So two examples there. One is the sill condition, and one is a sort of, a thicker wall in part of that wall. So what our software will see is if the sill, for example, is set to be room bounding, our software will actually take the line of that sill as the wall. And it will then make the external wall a shading element. Okay, so you don't really want that. And it would cover up any windows that were in there and that sort of thing. So just by setting the sill, the vertical and the horizontal of the sill to be non-room bounding, it will then go back to the line of the wall, and that's what you want. And the same here, if you set, well, exactly the same principle. So just set the wall to be the room bounding element and the bit that kicks in to be non-room bounding. Michelle's going to go through all this in more detail than me. Building layers of construction, again, will create the same sort of result. So it will take the inner surface of that to be the wall, and then it will take the external layer to be a shading surface. What we would do there is to set the internal, that layer to be non-room bounding, okay? We actually define constructions not by building them as individual layers, we just define them by the materials that they're made up of and the thicknesses. Room separation lines create their own set of problems. And then this just goes on to explain about using the correct family types. So for shading, it's got to be a roof or a mullion family. What doesn't translate as shading is a floor family or an in-place system family. So it just goes through and explains, again, how our software is understanding the geometry that it's being presented with. I'll just finish off with this one. We have built in, the plugin's probably in its 4th iteration now, or maybe even 5th iteration. And over time, we've refined, the functionality within there. We've built in some healing tools. So the plugin from Revit will deal with these healing tools automatically. You don't have to worry about this as a user. If you are importing GBXML files from other packages, you will have to go in and actually key in the commands. Again, these are set out within the documentation. And all they do, as the name suggests, is just tidy up the model. So it makes it a lot easier when you come to do any analysis on it. Okay, thank you.